welcome to this episode of Night Sky News for January 2022 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you can look out for in the night sky in the next few weeks, and we chat about what's been happening in space news in the past few weeks. There's chapter titles down here if you want to skip ahead to any specific news story, like the James Webb Space Telescope updates, and any scientific papers I mentioned will also be linked in the video description down below if you fancy reading them by yourself. So without any further ado, let's kick things off and start by looking up. Now, at this time of the year in the night sky, the star of the show really is the constellation of Orion. It's really prominent in the sky from just after sunset to the sort of small hours of the morning. Now, the further north you are, the closer Orion will be to the horizon, especially just after sunset, whereas the further south you are, in the southern hemisphere, for example, it will be much higher in the sky, passing right through the zenith for those of you near the Tropic of Capricorn. Now, there's plenty to look for in and around the constellation of Orion, including 5 of the top 10 brightest stars in the night sky. You've got Sirius, the dog star, in nearby Canis Major. You've got Capella in nearby Auriga, Procyon in nearby Canis Major, and then you've got the blue star Rigel and the red star Betelgeuse in Orion itself. Now, these stars actually form what's known as the winter hexagon around the constellation of Orion in the night sky. And it's one of my personal favorite things to look for because, like, once you've seen it, you can't unsee it. So if you start from the blue star Rigel and then you head across the brightest star Sirius up to Procyon, to Castor and Pollux, the twin stars in Gemini, across to Capella, down to the reddish Aldebaran in Taurus as well, the eye of the bull, and then back down to Rigel again, you'll make this huge hexagon on the sky. This is something that's great to look out for if you live in and around a big city, right, where there's lots of light pollution. Because sometimes when there's no light pollution, there's lots of faint stars there. And, you know, you can't pick out the brighter ones for just this mess of a scattering of stars. But in a city, all you'll be able to see is the sort of brightest stars on Orion and then these 6 stars ringing it as well. So it should be fairly easy to pick out. While you're there, along with the winter hexagon, look out for the fuzzy patch under Orion's belt, the 3 stars in the middle. This is what's known as the Orion Nebula. It's a big region, like a big cloud of gas, forming lots of new stars. And you can kind of pick out that there's like a fuzzy, not star-looking thing there with like just your eyes. But if you want to like reveal it and make it a little bit brighter, you can try like a long exposure shot on your phone, like a night mode shot. Or if you have binoculars around the house, break those out and they'll reveal it in much more detail. While you're checking out Orion in the early evening sky, turn towards where the sun actually set and try and catch Jupiter while you still can in that evening sky. It's only around for a few hours after sunset, and again, this should be visible wherever you are in the world. By mid-February, Jupiter's going to have moved too close to the sun from Earth's perspective for us to be able to see it anymore. The sun will just wash it out. And then we'll have a couple months without Jupiter while it sort of passes behind the sun from our perspective here on Earth. We'll have to wait until mid-April again before it pops out the other side and we end up seeing it in the morning sky. Now, actually, most of the planets we can currently see at the minute through January and February actually are in the morning sky as well. It's one benefit, at least for us up here in the northern hemisphere where the sun is rising really late, that we actually can maybe catch this in the early morning before we start work. It's Venus and Mars that are around at the minute in January in the east towards the sunrise. Venus, the much brighter of the two, and Mars, as always, looking that little bit reddish. And then, of course, my favorite thing, the toenail moon, or the crescent moon as it's actually called, will join them on the morning of Saturday, the 29th of January. If you're up early on a Saturday and you have clear skies, look out for that. By the 9th of Feb, Venus will actually reach its maximum possible brightness. And that's all to do with the relative position of the sun and the Earth and Venus at that time, making sort of like a perfect right angle triangle, which means that we get the maximum amount of reflected light off Venus to us. And also a few days after that, on the 13th of Feb, it will reach its highest point in the sky that it's possible to, and then it will start dropping again night after night closer to the sun as it sort of loops its way around the other side of its orbit from our perspective. So this is the time that you want to look at Venus, this sort of mid-February time when it's nice and high in the sky, the sun will have set by the time you can still see it and it'll be nice and dark. That's when you should break out binoculars or a telescope and actually look at the shape of Venus as well. Because you'll see if you do that, it doesn't actually form, a nice circle shape because of where it is in comparison to the sun and Earth in its orbit. when making this right angle triangle, what we actually see is a crescent-shaped Venus, and it looks incredible if you can see it through binoculars or a telescope. After mid-February, start looking for Mercury rising in the morning sky as well, so that we'll have actually 3 planets, Venus, Mars, and Mercury. Now, the further north you are, the harder time you're actually going to have spotting Mercury because it's going to be so low on the horizon. But those of you in the southern hemisphere should spot it a little bit more easily because it's much higher in the sky. If you're lucky, you might even catch a little glimpse of Saturn in the southern hemisphere, but most likely it's going to be too faint to see still in the glare of that very bright sunrise. We're just going to have to be patient and wait for Saturn to rise just that little bit higher in our morning sky, sort of through late Feb, early March as well, is when it will return to us. Right, I think that's enough for looking up at the night sky. Let's come back down to Earth with a bump and chat about what's been happening in space news in the past month. The big news this month is obviously the James Webb Space Telescope, or JWST as we like to call it. It launched on Christmas Day 2021 and has since fully and successfully folded out from where it had to be folded and squished down to fit in ESA's Ariane 5 rocket. And in that process, it surpassed 344 single points of failure that if any had have gone wrong, it would have scuppered and scrapped the entire mission. So it was a very nervy time for everyone at NASA, ESA, and around the astronomy and astrophysics community. Everyone was biting their nails, but thankfully it all went off without a hitch. What's more is that because its launch on ESA's Ariane 5 rocket was so perfect, Webb didn't have to use any of its fuel stockpile to bring it back onto the right trajectory, like do like a course correction to bring it onto the right path to its eventual orbital point at L2, this Lagrangian point that's very stable where it will orbit the sun, which means more fuel for science observations. And there was lots of hints of this in early January that it was going to last longer than what we'd all expected, which was 5 to 10 years. And then on the 8th of January, the Webb project manager for the whole mission at NASA, Bill Oakes, announced that they'd run the math and they think that JWST has enough fuel for 20 years of science observations. 20 years! I mean, this is huge. It's incredible. You could almost hear this like collective from the entirety of the astro community when he announced it, like this sort of like shock and disbelief, and then just like pure joy. Like, can you imagine how much more science we're going to be able to do now with this telescope, now that we have it for 3 times longer than we originally thought we were going to have it for? We can do follow-up observations. There'll probably be more like serendipitous discoveries as well. I was already excited for the James Webb Space Telescope going up and hopefully working and everything being okay. But now the idea that we have it for 20 years is just phenomenal. But I'm getting a little bit ahead of myself here because there are still lots of processes and steps we need to go through before the James Webb Space Telescope is actually operating as a telescope as we need it to do. And the first thing that needs to be done is the telescope needs to be focused. And for that to happen, we need to pull the mirrors out to the correct position. So during launch, all those 18 individual hexagonal mirrors were tucked in tight, so they didn't get shaken around too much by all the accelerations and vibrations during the rocket launch. Now those mirrors need to be pushed out a little bit so that they unlatch from these little metal pegs that were all holding them in place during the launch. And it's not by much they need to be pushed out. It's only around about 1.25 centimeters or 12.5 millimeters as well. Or it's about half an inch if you speak in like old-fashioned units as well. And that'll allow the mirrors, once they're out that far, to tip and tilt so that the telescope can be focused. Now, the things that actually control that pushing out of the mirrors, they're called actuators, which are essentially these like a little electronic devices that cause motion, right? And they're electronically controlled, so you can control them from the ground, etc., etc. But they're designed to be incredibly precise, these actuators, because that's what we'll tip and tilt with the telescope mirrors with eventually to focus it to incredibly high precision. So they're designed to be able to make these tiny, tiny changes of only about 10 nanometers or so, which is about 100 times bigger than an atom, just to put that into context. So trying to push out these mirrors with these incredibly precise, tiny movement actuators takes a long time. They've been doing around about 1 millimeter a day on each mirror, so the whole process is actually going to take around about 10 days just to put this into context, how long this tiny change will move. We're currently still in that process now as I'm filming this on Monday, and then also we should still be on Thursday when this video comes out as well. But by the end of this week, on the 23rd of January, the mirrors should all be popped out as far as they can go. And you can check up on the progress of that using NASA's Where is Web website, which I'll link in the video description down below. So once those mirrors are popped out, we can then tip and tilt them to focus it, because essentially at that point is when the telescope will be cross-eyed, right? Each individual segment will be looking in an ever so slightly different direction, which means you won't get a clear image. In fact, if you point at a bright star, you're going to get 18 individual images of that star on your detector. So essentially the next phase will be to tip and tilt each mirror into the right alignment to bring that image of the star that mirror sees into the very center, so instead of 18 images, you just get one very clear image with all the mirrors working together to give us a giant mirror 6.5 meters across. That won't start straight away though. Once all the mirrors are popped out, the whole process takes a few months actually to make sure it's like properly focused. But also because the telescope will be starting to arrive at its final orbital position of L2, where it'll hopefully spend the next 20 odd years doing science. So it should start getting there, and we should know if it's there all right by around Monday, the 24th of January. That's 29 days post launch. And essentially what it's going to do is arrive at L2 like a really good golf putt, like go really fast at the start where it's been given the acceleration by the club, just slow down perfectly until it sort of drops in the hole here being orbiting around L2, this stable point in the Earth-Sun system, gravitationally speaking. And I know a lot of you have been asking, why does James Webb orbit L2 rather than, just being stationary there if it's a very stable point that it would stay there? And it's a fairly simple answer. It's all to do with solar power, the amount of power that James Webb can actually get from the sun to run all of its electronics, essentially. So yes, it's been placed at L2 so that it is further away from the sun, so the infrared radiation from the sun is less, and so the sun shield that it has, this huge tennis court size thing, doesn't actually have to work as hard, doesn't have as much infrared radiation to reflect to keep the instruments on the other side incredibly cold. But also, if you think about the position of L2 and just the geometry of it all, L2 is actually shadowed by the Earth and the moon to some extent as well, right? If you looked back, essentially what you'd see is an eclipse of the sun by the Earth. So the solar panels at L2 would get 60% less power because of this shadowing. So this is why James Webb orbits L2, actually with an orbit distance that's larger than the Earth-Moon distance as well, in order to keep it out of the shadow of both Earth and the Moon. And that also helps regulate the temperature of all the instruments on board too, because if it was on a smaller orbit and in and out of shadow all the time, it'd also be in and out of hotter and colder regions that would cause these temperature swings in the instruments too, that would mean you wouldn't get as good of a performance. So that's what we've got to look forward to in the next few days and also the next few months as well. Once it's there at L2, there'll be about 5 months or so of focusing and commissioning, turning on all of the instruments, checking they're working okay and as planned as well before actual science observations can start. And also we just have to continue waiting for those instruments to cool down now the sun shield has been unfolded. It looks like it's cold now, but it has to get even colder. Now, if you cannot wait to get your hands on some data from the Webb telescope, maybe this will tide you over in the meantime, because the MaNGA survey has dropped its final data release. It's made public observations of over 10,000 galaxies. And this is actually what I use to do my research on growing supermassive black holes and their effects on galaxies. And I know a lot of you are always asking me, is astronomy data public? Where can I find it to do my own research? So I'll link the site below that it's been made public where you can explore and download the data. Now, MaNGA is a very special type of galaxy survey. Instead of one observation per galaxy, it splits galaxies up and observes little sections of them, kind of like a jigsaw or a mosaic, right? So you get this really detailed look at what's going on inside the galaxy. Because at each point, it also takes the light and splits it into the different colors or wavelengths of light. So you end up with this 3D picture of the galaxy, right? We call it a data cube. And you can either think of it as a spectrum at every point, or an image of the galaxy in every color or wavelength. So you get a huge amount of detail on each of these 10,000 galaxies. Like, the data volume for this survey is absolutely ridiculous. Now, I'm using this data to see if you can spot the effects of a burp from a supermassive black hole, like moving through a galaxy. But I've got colleagues doing all sorts with this data, loads of different things, from, how do galaxies spin to how do the stars form, and where do the stars form, and where do the stars stop forming as well in a galaxy. There is so much going on with this survey. The release of all this data came as part of a press release for the American Astronomical Society's 239th meeting, which was all virtual, and it had a wonderful interactive mosaic image of all the galaxies, which was made by my colleague Karen Masters, who I wrote my latest research paper with as well. More on that next week. I'll link though the cool mosaic that she made down below, because it really is absolutely stunning, along with a link to all the other press releases that came from this virtual meeting too, because there was a lot of them. I could really only highlight one. So there's everything from the 1,000 light year wide gas bubble surrounding the solar system to the streams of torn apart star clusters around the Milky Way that help us probe dark matter. There's both slide decks and press releases and live streams to go with them all, so browse to your heart's content. And finally, a paper was published this month that got the internet very excited. It was called Moons Are Planets: Scientific Usefulness versus Cultural Teleology in the Taxonomy of Planetary Science. And I'm sure you're thinking, why did the internet get so excited about this? And it's because this paper essentially argued for a new, different definition of a planet. One that would see Pluto reclassified as a planet, vindicated in the eyes of the internet. But not only that, it wouldn't just see Pluto classified as a planet, it would also see like hundreds of other objects in the solar system classified as a planet, from our own moon to moons of Jupiter and Saturn alike as well. So as a refresher, right, back in 2006, the IAU, the International Astronomical Union, voted on this specific definition of a planet. Number one, that it had to orbit the sun. Number two, that it was heavy enough that gravity would be strong enough to turn it from a knobbly potato to something that was round. It's something we call hydrostatic equilibrium. And number three, that it had to gravitationally clear its orbit. Now, famously, Pluto fell down on criteria number 3. It hasn't cleared its orbit, and that leaves us with just 8 planets in the solar system. Now, that was motivated by the fact there was lots of other Pluto-like objects discovered on the edge of the solar system in a region known as the Kuiper Belt, kind of like the asteroid belt. But in this paper by Metzger and collaborators, they argue that that definition is wrong. And if you understand the history of the use of the word planet, then you realize that the use of it to mean something that orbits the sun is not an astronomical one, but an astrological one. Astronomers had called moons planets for centuries, like the Galilean moons of Jupiter, for example, were first referred to as the Galilean planets. Whereas astrology had stuck to only calling, like the big 6 of like Mercury to Saturn planets for centuries, because they put some special importance on things that specifically orbited the sun, because supposedly those were the objects that had an influence on our lives as humans. They don't, there's no scientific evidence for that whatsoever, but that terminology of using the word planet to mean something that orbited the sun and the word moon to mean something that orbited another planet, like our own moon, came into common use in the public anyway, even though astronomers weren't using that in their scientific papers. And this paper that was published this month gives lots of examples of that, from Galileo in the 1600s all the way through to the very early 1900s as well. The problem was that then there was a really large gap from around about 1910 to about 1955 where very little studies were done on planets in the solar system. And that's because astronomers got very distracted in the 1900s, in the early 20th century, because, well, they realized lots of mind-blowing things, like galaxies were islands of stars in their own right, and that the universe was expanding, and that the best theory we had to explain its evolution was the Big Bang. And so for around about 40 odd years or so, there was very little done on planets until at least sort of the 50s and 60s, when the space race started, and then we started sending missions to the likes of Mars and Venus, and those works picked up again. But by that point, enough time had passed that the astronomers that were then coming in to do that planetary research and publishing all these papers had grown up learning the public use of the word planet and moon, and not necessarily the scientifically motivated one of just calling everything a planet that was used in the 1800s and 1900s, because, you know, they didn't have the guidance of that earlier generation of astronomers because they were no longer in the field anymore, like 50 odd years later. And so it's this that the authors of this paper that was published this month, they argue that this is actually what biased the IAU's definition of a planet in 2006. And therefore it's not scientifically motivated because of this sort of dearth of planet research in the early 20th century that led to this misuse of the words moon and planet. Instead, they argue that the definition shouldn't be based on orbit, either what the object orbits or if the object has cleared its orbit, but actually on the nature of the object itself. They keep this idea of hydrostatic equilibrium, that gravity should be strong enough that it should have rounded it from a lumpy rock of potato shape to, you know, something nice and round, but also not strong enough that, you know, nuclear fusion has been triggered, because then you would have a star. But also that you have some geological complexity in there as well. Things like volcanism, chemistry, an atmosphere, oceans, a magnetic field, or even tidal heating as well from sort of squishing and stretching coming close to a big object. And no single planet in the solar system ticks all those boxes either. You have this very messy Venn diagram when you consider all of those things. So I think this idea is very interesting, if perhaps a little bit Earth-centric, because I think apart from tidal heating, Earth does tick all of those boxes, so maybe there's things we aren't thinking of necessarily. But I think this idea does get you to challenge, you know, sort of like your preconceptions of what is a moon versus a planet, especially when you consider the fact that Jupiter's moon Ganymede and Saturn's moon Titan are actually larger in size than Mercury. And I think the more I think about it, the more I'm coming round to the idea, because I think the press release for this paper was released before the actual paper itself. So the first I heard about it was in, you know, sort of like the media, you know, attention grabbing headlines of like, should Pluto be a planet again? And I had a very like knee-jerk reaction of no, just because of like all of the firefighting that us science communicators have done over the years, you know, to explain why Pluto isn't a planet to the very angry Pluto fan club. But at the end of the day, the moons of the solar system, especially of Jupiter and Saturn, could prove the most interesting in terms of the evolution of life. And some of these are the most volcanically active in the solar system as well, just like the activity we have here on Earth. So what makes them any different? You know, so what should it matter if they're technically in orbit around Saturn or Jupiter? They're still also technically in orbit around the sun too. They're just being shepherded along by Jupiter or Saturn, right? So if this new definition, you know, if it was actually, you know, agreed upon and accepted and voted on by the community as the new definition we were going to take for a planet, and that meant that the likes of Io and Enceladus and Ganymede and Titan, they were all classed as planets, then you know what, I think I'm all for it. Even if it means that Pluto would also be classified as a planet again as well.
I want to file a declaration that Pluto is a planet.
Alright, that's it for Night Sky News for January. Next week's video will be all about my latest research and that paper that I've just published, all about the colours and shapes and galaxies and what that can tell us, so look out for that one. Until then though, if you snap any pictures of the night sky, either with your phone or with a snazzy big camera or something, send them my way over on social media and I will share my favourites. And so all that's left for me to say is happy stargazing, everyone. So that whole process will probably take about 10 days as well. We're still in it now on time of recording on Monday, and then they should still be in the process as well on Thursday when this video comes out. But by Sunday, the 23rd of Jan, all the mirrors should fully be like pooped out by then, and then pooped out. Popped out. Teleology? Yeah, it's got to be teleology. Or maybe that's just like, thinking of television. Yeah, it's like television. Teleology? Teleology? Teleology. Should I look this up? So if this definition means that the likes of, Io or Titan or Enceladus or some Enceladus, Sean Connery is back. Tweaking all these mirrors, oh, can anybody see? Is anybody waving back at me?